Welcome back to part 2 of chapter 17. I wanted to go ahead and do this titration example that we did in class, and that's in your notes. And it is a strong base and a weak acid, and we start them all out the same. I see that I have a weak acid. I want to know how many moles of that weak acid am I dealing with. So I go back to molarity equals moles over liters. I know from the problem that the molarity is 0.1. I know that I have 40 milliliters. That equates to 0.04 liters. So what this tells me is that I'm dealing with about that many moles of H plus from the acid. Okay? On letter A, it says the volume required to reach the equivalence point. Okay, so here's what I got to figure out. The equivalence point means I would have just as many OHs as I have Hs. All right, that's what equivalence means. The moles are equal. So if I look at the base, what's the base I have here? KOH, molarity equals moles over liters. In the problem, the molarity of the base was 0.2. If I'm at the equivalence point, the moles of hydrogen have to equal the moles of hydroxide. So that's where that number comes from. And I'm going to look to see how much of that base I have to add. When I solve for X, I get that number, which I multiply it by 1,000, means I have added 20 milliliters of base. So that's letter A. Letter B says, what's the pH after adding 5 milliliters of base? So this is all A. Now I'm at letter B. So I'm adding 5 milliliters of base. Okay, here goes. Always starting with molarity again. I know the molarity is 0.2. I know I'm adding 5 milliliters of base. Okay, so that's where this came from, 5 divided by 1,000. So what that means is that in this solution right now, that's how much moles of OH I have. Okay. What I can use is my little Henderson Hasselbach. Okay, and I know that the pKa is 3.34. I know that the concentration of the base, the OH is the base, is that. And I know that the concentration of the acid should be that, but I'm going to lose that much because it's going to react. So that minus that is that, and I put that in. Shazammy poo-poo. Okay? And then letter C says, what's the pH at 1/2 of the equivalence point? All right, so I do my Henderson Hasselbach again. pKa is 3.34. And if I'm at the halfway point, this is the whole way point to the equivalence point. The halfway point would be half of that. So if I take this number and divide it by 2, that's going to be 0.002. And this is going to be 0.002. Okay? Why is that 0.002? Because that's where I am there. And then that's going to be that. If I'm halfway to the equivalence point, I have to have half of that, and I have to have the same amount of OH. Okay, the last thing I'm going to talk to you about really quick is some solubility. And let me just erase this. The solubility stuff I think is the easiest in this chapter because the calculations are just kind of short, sweet, and to the point, and you start to see a pattern. Okay? And we will beat a dead horse with all of this stuff in class, so no worries. All right. Molar solubility. Okay, calculate the molar solubility of PbCl2 in pure water. All right, what am I talking about when I talk about molar solubility? All right, so Pb, or lead 2 chloride, is a solid. And it's going to hit water. And when it hits water, it's going to break down into its ions. Okay? So all I did there is I broke it down into its ions. Again, I'm going to use a different, I'll use my darker marker again. Now, when you go to write what is called the solubility product. Okay. It is products over reactants, but it's pretty much just going to be what's on that side. Okay. Now, if you look in your textbook, you get the values for several of these. And for this one, the KSP value is that. Now, I'm going to show you a little shortcut. If when you look on this side, on the product side, and there's 1, 2 items, these are going to be set up the same way. In this case, there's 1 plus 2, so there's 3. Anytime you look on this side and there's 3 of those, this is your setup. And we'll go more in detail about that in class. So 1, 2, 3, that's really easy. I can solve for x. X equals that. If I had looked on this side and it was 1 plus 1, this would just equal x squared. Okay? So that is molar solubility in a nutshell. All right? And that's pretty much the important stuff of chapter 17 from your notes. Come see me if you have questions. I hope this video was helpful. And just remember, we are like running down that hill, almost done. 3 chapters to go, only 30 some days left in school. Can't wait to see you in class, guys. Bye.